Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you look for videos explaining topics in just about any college mathematics course, please consider subscribing, checking out playlists, watching videos, and then liking, commenting, sharing those videos. Those are all really simple interactions that you can do that would greatly help us out, and therefore we would appreciate that. Let's go ahead and get into the current video. I want to take a look at dividing complex numbers. Okay, so first and foremost, dividing complex numbers, I've always felt that it's kind of misnamed because we're not, I guess we are simplifying a division, but it's more like just rationalizing the denominator, okay, but we call it dividing complex numbers. And the goal here is to convert a ratio of complex numbers to an equivalent complex number whose denominator is real. So I guess rather than saying rationalizing the denominator, because the denominator might not end up rational, let's say I'm going to realize the denominator or something like that. I don't know, I just made that term up. But essentially I need to make the denominator real. Let's see how we do that. Let's say I wanted to divide 2 plus I by 1 plus I. Okay, so I want to divide 2 plus I by 1 plus I. Here's the setup for it. What I'll do is I'll start by writing it as, well, it looks like a fraction. So 2 plus I divided by 1 plus I. And really, the technique does not involve division in any way. I actually am going to do 2 multiplications. Here's the way I do it. I take the conjugate of the denominator, and as a reminder, the conjugate of a complex number means I simply take the sign in between the real and imaginary part and switch it. If this is positive, I make it negative. If it was negative, I would make it positive. I use the same real and imaginary parts, so 1 and I just have to have these as opposite signs. And then I'm going to do the same thing to the top, so 1 minus I, okay, to keep the fraction, fraction balanced, right? So then on the top, I'm going to FOIL that, and the bottom, I'm going to FOIL that as well. On the top, I'm going to get 2 times 1, which would be 2. 2 and negative I would be negative 2I. 1 and I and 1 would be plus I. Plus I and minus I would be minus I squared. And then when I multiply down here, I get 1 and 1 is 1. 1 and negative I would be negative I. I and 1 would be plus I. I and negative I is negative I squared, okay? And let's see what happens. Well, remember that I is the square root of negative 1, right? I, as a reminder, is the square root of negative 1. Therefore, I squared is negative 1. That means that negative I squared is actually positive 1. And, of course, that occurs down here as well, so positive 1. And also, let's look at that denominator. Negative I plus I, those actually cancel. And then my entire denominator becomes 2 because I've got 1 here and 1 here. What happens on the numerator? 2 and 1 gives me 3. And then negative 2I and I gives me minus I. So I get 3 minus I divided by 2. This number is equivalent to this number here that I started with, but notice that this does not have an imaginary number in the denominator, so this is a strictly real number. That means when I take this number 2 plus I divided by 1 plus I get 3 minus I over 2. Okay? Let's do one more example. All right, let's take 4 divided by 3 minus 2I. Okay, so 4 divided by 3 minus 2I. Technically, 4 is a complex number. It's also a real number. 3 minus 2I is a complex number. That's not a real number. Okay, so my goal is to get this I out of the denominator. The way I do that is multiply the top and bottom by its conjugate, Remember, I had mentioned that I just changed the sign here, so instead of a minus, I'll have a plus. 3 plus 2i over 3 plus 2i. And I go ahead and multiply that out. 4 and 3 would be 12. 4 and 2 would be 8, so 12 plus 8i. In the denominator, 3 and 3 is 9, plus 6i, minus 6i, minus 4i squared. Well, notice that the middle terms cancel, 6i and minus 6i, and negative 4i squared is actually equal to positive 4. Therefore, I come up with 12 plus 8i divided by 13. Now, depending on the context, sometimes we do like to separate into the real and the imaginary parts. If I wanted to do that here, that'd be 12 thirteenths plus 8 thirteenths I. Just like up here, I could have written 3 halves minus 1 half I. Sometimes it doesn't matter, sometimes it might. But anyway, to divide complex numbers, I just multiply top and bottom by the conjugate of the denominator with the goal of making the denominator of the end result strictly a real number. Thank you for watching. Please consider subscribing.